Hi everyone, I am Dr. Harikrishna Mulam, Associate Professor, Department of EIE. In this lecture, we will see one more problem on time response analysis. So the problem is measurements conducted on a servo mechanism show that the system response to be C of t is equal to 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t. So there is some system, okay, and its response is C of t is equal to 1 plus 0.2 into e power minus 60t minus 1.2 e power minus 10t. Let us write it. So C of t, response of the system, okay, output of the system C of t is 1 plus 0.2 into e power minus 60t minus 1.2 e power minus 10t. Then when subjected to a input of a unit step, so the input is a unit step input. Input in control system is represented as R of t. Unit step input, mathematically it is written as R of t is equal to 1. Now obtain the expression for closed loop transfer function. Okay, so we are asked to find the closed loop transfer function. Whether it is closed loop transfer function of the system or open loop transfer function of the system, the definition is it is the ratio of Laplace transform of output to that of Laplace transform of input. So C of S by R of S is the formula for closed loop transfer function. So you need to find C of S first. Okay, C of t is given. You need to find C of S. Okay, in order to find C of S output in S domain, okay, from the output in time domain, just take the Laplace transform. And so the Laplace transform of 1, okay, we know that Laplace transform of 1 is equal to 1 by S plus 0.2 is a constant. The Laplace transform of e power minus at is equal to 1 by S plus a. Therefore, the Laplace transform of e power minus 60t will be 1 by S plus, okay, in place of a, 60 is there, okay, minus a minus 60 is there. So 1 by S plus a is the formula. So 1 by S plus 60 minus 1.2, again use the same formula, e power minus 80 is equal to 1 by S plus a. Therefore, this e power minus 10t can be written in its Laplace transform is 1 by S plus 10. 1 by S plus 10. Now, just take the LCM of this. So, C of S is equal to S into S plus 60 into S plus 10 is the denominator, and for this term the numerator is S plus 60 into S plus 10 plus 0.2 times, for this term the numerator here that you will get is S into S plus 10 minus 1.2 into, for S plus 10 term, the numerator that we get is S into S plus 60. That is equal to, denominator is S into S plus 60 into S plus 10, whereas the numerator is S plus 60 into S plus 10 is S square plus 60S plus 10S plus 600 plus S into S is S square 0.2. So 0.2 s square plus s into 10 is 10s. 10s into 0.2 is 2s. S into s is s square minus 1.2 is minus 1.2 s square. S into 60 is 60s into minus 1.2 is minus 72. Yes. Okay. So if you see here, s square is there. S square is there. Then 0.2 s square is there. Together it is 1.2 s square. It gets cancelled with minus 1.2 s square. So this gets cancelled. Then 60s plus 10s is 70s plus 2s 72s gets cancelled with minus 72s. So this gets cancelled. So finally the C of s output in S domain is equal to 600 by s into s plus 60 into s plus 10. This is C of s. In order to find the closed loop transfer function, you need to get it by Laplace transform of output by Laplace transform of input. So C of s is this, R of s. So R of t is 1, therefore R of s is the Laplace transform of 1, which we already told it as 1 by s. 1 by s. Therefore we got R of s and C of s. Therefore the closed loop transfer function is equal to Laplace transform of output C of s is 600 by s into s plus 60 into s plus 10 whole divided by R of s is 1 by s. So the denominator of numerator has s, gets cancelled with the denominator of denominator, which is s. Therefore finally closed loop transfer function of this system is 600 by s plus 60 into s plus 10, which can also be written as 600 by s square plus 60s plus 10s, 70s plus 600. This is the closed loop transfer function of this particular system. So we have found the expression for closed loop transfer function of the system. What else do we need to find? We need to find undamped natural frequency of the system, which is represented as omega n, and damping ratio of the system, which is represented as zeta. If you have the closed loop transfer function of the system and if you want to find this zeta and omega n, always compare this the transfer function of the system with the transfer function, the standard way of representing the transfer function of a second order closed loop system, that is omega n square by s square plus 2 zeta omega ns plus omega n square. Again, give preference to comparing the denominator term of the transfer function with the denominator term of the standard closed loop second order system transfer function. So if you compare these two denominator terms, okay, we can understand that omega n square is equal to 600. Omega n square is equal to 600 and omega n is square root of 600, which is equal to 24.49 radians per second. Then 2 zeta omega ns is compared with 70s. Therefore 2 zeta omega n is equal to 70. Therefore zeta is equal to 70 by 2 into omega n is 24.49 radian per second, and if you find zeta value you will get it as 1.43. As the zeta value, damping ratio of the system, is greater than 1, this system is a over-damped system. This system is a over-damped system. You can understand this here itself. We could get the transfer function of the system as 600 by s plus 60 into s plus 10. So from this, we can understand the roots of the denominator term of this transfer function are s is equal to minus 60 and s is equal to minus 10. The roots of the denominator term are minus 60 and minus 10 are called as poles of this system, closed loop poles of the system. And these closed loop poles are real, they are real and unequal, they are not the same. If the poles of the system, closed loop poles of a second order system are real and unequal, again you say that such a system is called as over-damped system. So this is about solving this problem related to time response analysis. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.